In this video, we will learn about stoichiometry, that is, calculation based on chemical equations. This word stoichiometry is derived from two Greek words. The first one is stoichion, meaning element, and metron means to measure or measure. So stoichiometry, sometimes also called as reaction stoichiometry, it deals with the calculations of quantitative relationship of the reactants and the products in a chemical reaction. So when reactants react to form products in a chemical reaction, they do so in a particular manner. For example, in the reaction we have N2, that is nitrogen gas, plus 3 hydrogen gas are giving us 2 ammonia gas. So exactly 1 mole or exactly 1 molecule of nitrogen is reacting with exactly 3 moles of hydrogen to give 2 moles of ammonia. This information, in combination with the law of conservation of mass, allows us to calculate accurately the amount of reactants consumed in a particular reaction as well as the products formed in this reaction. So the balanced chemical equation conveys the following information. For example, this equation we have, it shows that one molecule of nitrogen combines with 3 molecules of hydrogen to form 2 molecules of ammonia. Similarly, 1 mole of nitrogen combines with 3 moles of hydrogen to give 2 moles of ammonia. And we know that 1 mole of nitrogen has 28 gram mass. So 28 gram of nitrogen combines with 6 gram, because in 3 moles of hydrogen we have 6 gram mass, as well as in ammonia 1 mole of ammonia have 17 gram. So 2 moles of ammonia will have 34 gram of ammonia. Also, we can write in terms of volume if the reactants and products both are in gaseous form, that 1 liter of nitrogen combines with 3 liters of hydrogen to form 2 liters of ammonia at STP, that is standard temperature and pressure condition. The quantitative information conveyed by a balanced chemical reaction helps in a number of quantitative calculations. These calculations are of the following type. The first one is mass-mass relationship. Example, mass of one of the reactants or the products is given and the mass of the other reactants or products has to be calculated. Then the second is mass-volume relationship. So in this, we simply know that we are given with the mass of some reactant or product. Then we need to calculate the volume of some other reactant or product whose data is missing. Now the second concept is limiting reagent. Many a times, the substance in a reaction mixture are not present in exactly the same amount as required by that chemical equation. What does it mean? It means that we have this equation, 1 moles of ammonia is reacting with 3 moles of hydrogen to produce 2 moles of ammonia. But it sometimes happens that we in actual condition we have 1 mole of ammonia, but we might not have exactly 3 moles of hydrogen. We might have 2 moles of hydrogen, we might have 4 moles of hydrogen, depending upon the availability. So that where the concept of limiting reagent arises. The reactant present in lesser amount than required. So here in this reaction we can say that we have 1 mole of ammonia, but the hydrogen, suppose we have 2 moles of hydrogen. So the amount of hydrogen required is 3 moles, but how much we have only 2 moles. So we need more hydrogen in order to react, in order to complete this reaction, but we don't have. So that is, the reactant present in lesser amount than required is consumed up first in the reaction. Obviously 2 moles of hydrogen will definitely react, and after that no further reaction takes place whatever be the amounts of other reactants present. Hence, the reaction that is consumed first, in our example it was hydrogen, it will limit the theoretical yield of the products formed and is therefore called as the limiting reagent or reactant. In doing stoichiometric calculation, this aspect should also be kept in mind. So first one is type 1 calculations involving mass-mass relationship. So the question is, how many grams of magnesium oxide will be obtained by heating 5 gram of magnesium carbonate? So simply just write the reaction, that is MgCO3 on heating MgO plus carbon dioxide. It is clear from the reaction or the balancing the reaction that 1 mole of magnesium carbonate is producing 1 mole of magnesium oxide along with the 1 mole of carbon dioxide. So we can say that 84 gram of magnesium carbonate will give us 40 gram of magnesium oxide. That is here. Now what we have to calculate is, we have to calculate how much magnesium oxide will be produced by 5 gram. So by simply unitary method, we can say that 1 gram of magnesium carbonate will give us 40 by 84 gram of magnesium oxide. And for 5 gram, we will multiply with the 5. So 5 gram of magnesium carbonate will give us 40 into 5 divided by 84. That is 2.38 gram of magnesium oxide. Then the second we have, how many grams of AgCl precipitate when a solution of AgNO3 containing 5.75 gram of AgNO3 is added to an excess NaCl solution. Now let's write the balanced chemical equation. First of all, this is the chemical reaction. This is the mass of AgNO3, that is 172. We have NaCl in excess, means as per this reaction, we can say that 1 mole of AgNO3 is reacting with 1 mole of NaCl. But excess means we have the amount of NaCl which is more than 1. So as per, we need only 1 mole of NaCl, but we have more NaCl. So that's why it is written as excess. So the products are going to be AgCl plus NaNO3. So all the reaction is balanced. So we can say that 1 mole of AgNO3 is reacting with 1 mole of NaCl to give us 1 mole of AgCl along with the 1 mole of sodium nitrate. So we'll write their atomic mass. So as NaCl is present in excess, the other reactant, that is AgNO3, is going to be the limiting reagent in this particular reaction, and it will limit the amount of AgCl formed. Thus we can say that 170 gram of AgNO3 is producing 143.5 gram of AgCl, or we can say that 1 gram of AgNO3 will produce 143.5 divided by 170 gram of AgCl. For 5.75, we'll multiply whole with the 5.75 and we'll get the answer as 4.85 gram of AgCl. Next, calculations involving mass volume relationship. From this equation, we have this equation: carbon on reacting with H2SO4, we are getting certain products. Mass, we need to calculate mass of carbon dioxide, carbon oxidized. So mass, this is sulfuric acid which is reacting as an oxidizing agent here. So we have to see mass of carbon oxidized by 49 gram of sulfuric acid. Then we are given with the relative molecular mass of H2SO4. Then second, we have to calculate volume measured at STP liberated at the same time. So this is the reaction which is here. We can say that 12 gram of carbon is reacting with 190 gram of sulfuric acid. Why 196 gram? 1 mole of sulfuric acid will have 98 gram, but we have here 2 moles, so we'll simply multiply 98 with the 2. So we can write it like this. So for, we have 49 gram of H2SO4. So 1 gram of H2SO4 will oxidize 12 by 196 gram, and 49 gram of H2SO4 will oxidize 12 by 196 into 49. That will be equal to 3 gram of carbon. So we'll get the answer as 3. Now we have to see how much SO2 will be produced at the same time. So we have 49 gram of H2SO4. How much SO2 it will produce, that is we have to tell. So here we can see that 2 moles of H2SO4 on reacting with 1 moles of carbon are producing 2 moles of sulfur dioxide. So we know that for 1 mole we have the volume 22.4 liter, and for 2 moles we will multiply it with 2 at STP. But we have only 49 gram of H2SO4. So we have to write that, first of all, 196 gram H2SO4 is producing 2 into 22.4 liters of SO2. Then we will simply write that 191 gram of H2SO4 will give us 2 into 22.4 divided by 196 gram. For 49 grams specifically, we will multiply that with the 49 and get the answer as 11.2 liters of SO2 at STP. The next we have phosphorus on reacting with concentrated nitric acid will give us this. We have to calculate the number of moles of phosphorus consumed and the mass of phosphoric acid formed, and finally the volume of NO2 produced at STP. So we have 9.3 gram of phosphorus. Here we can simply calculate the number of moles, that is given mass divided by molecular mass. So that will be 0.31. Here is the reaction. Now we have to calculate the mass of H3PO4 produced. So that will be simply by writing the reaction. We can say that 1 mole of phosphorus is giving us 1 mole of this H3PO4. So in terms of mass, 31 gram of phosphorus is producing 98 gram. So we'll simply write 9.3 gram of phosphorus will produce 98 into 9.3 divided by 31, that is 29.4 gram. Same for we can see that 1 mole of phosphorus is producing 5 moles of nitrogen dioxide. So we can say that 31 gram or 1 mole of phosphorus is giving us 5 moles of NO2 at STP. So 0.3 mole will give us 5 into 0.3, that is 1.5 mole of NO2 at STP. So we can calculate an volume of NO2 at STP when we have 1.5 moles, that is by multiplying 1.5 with 22.4 dm cube, that will be equal to 33.6 dm cube of NO2. I hope it is clear to you. Thank you.